Hey, so welcome back to Algebra 2. This is going to be our first assignment of the second marking period. So today counts for marking period 2, no worrying about marking period 1. And we're going to be working with something that I know you've seen before in Algebra 1, namely the quadratic formula. Now, you've seen the quadratic formula before. I'm not going to try to teach it to you for the first time. We're going to go over one example of how to use it, and then we're going to talk about a specific part of it called the discriminant, which tells us about the roots. This is going to be leading into our topic of complex numbers and imaginary numbers, and we're gonna, take a look at some cool Algebra 2 stuff. Let's take a look.
So today we're going to talk about the quadratic formula and the discriminant. First off, we need to know standard form of a quadratic equation. We've touched on this in the past, what standard form is. Remember, you have your a next to your x squared, you have your b next to your x, your c by itself, it equals 0. It helps to make a positive. We're also in decreasing exponent order because we have an exponent of 2, there's an exponent of 1, there's no exponent here. So, you've seen the quadratic formula in previous math classes, just a bit of a refresher. Once you've gotten an equation into standard form, you can plug into the quadratic formula. Your a just gets plugged in these two places. Your b gets plugged in here and here. Don't forget that negative that starts it all off. C only gets plugged in here. You plug in and you solve it out. And this plus or minus sign means that at some point you're going to split into two answers. One where you got something over here plus something, and one where you have something over there minus something. We'll do an example just to get the cobwebs off. So we're going to solve for all real solutions. And here's our equation. Well, it's not in standard form, so we're just going to subtract the 4n on both sides. 4n squared plus 20n plus 25 equals 0. Now it's in standard form. Now we can use the quadratic formula. Now, there's actually a little song to do it. It goes, to remember it, it's called Pop, goes by the name of Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, sorry for subjecting you to my singing. At least you're not my child who has to sing it more often. So, if I wanted to plug stuff in then, I'm just going to set up everything that I'm going to have to plug into. Cool. So my a up here is 4, because it's next to the n squared. So that means that I'm going to have my a is going to be right here. My b is the 20. And my c here is the 25. So b is going to be 20, so minus 20, 20 squared. And then c is 25. Cool. Notice I left the negative here. Has to always lead with a negative. That can cancel out if b was negative, by the way, so don't worry about that. And let's just simplify things a bit. Negative 20 plus or minus, that's going to be 400 minus 16 times 25, so also 400 over 8. So that means negative 20 plus or minus 0 over 8, negative 20 over 8, so negative 2.5. And that'll be our only answer here. We only have one answer because this, under the radical, cancel it out. Now, this actually brings us to our next point, the discriminant. That problem specified real solutions. Now, real solutions are just numbers that don't include the square root of negative 1. But we're starting to see square roots that do have negative numbers under them. And we can use a part of the quadratic equation to determine if we're going to have real solutions, if we're going to have what we call complex solutions, how many solutions we're going to have, all of that.
So this is our discriminant. It's a part of our quadratic formula. It's just what's under the square root. It doesn't include the square root. As you can see right here, this is just our discriminant. But we're going to use it and determine the nature of our roots. And the nature of our roots is if the roots are real numbers, if there are two roots, if there's one root, if they're irrational, if they're rational. And we have a nice little handy chart to take a look at that.
This I took right from your textbook. If this part is it's greater than 0 and it's a perfect square, you're going to have real, rational, and unequal answers. So for instance, if that equals 4, 25, 9, then you're going to have real, rational, and unequal. It's going to be rational because if it's a perfect square, the square root can be simplified fully. Now, if it's greater than 0 but not a perfect square, it's still going to be a real answer. It's going to be irrational and unequal. The real tells us the number that can be plotted and seen and all that. The irrational part here is just because it's a square root that we can't simplify. And the unequal part is just because we'll have two roots which are not the same. Now, this is like the problem we just saw. If it's equal to 0, the roots are real, rational, and equal. In that problem we just did, where the answer was negative 2.5, you still technically had two answers. They were two roots. The thing is, those two roots are both the same, so they're equal. Last but not least, if the discriminant is less than 0, then your roots are not real numbers. They're complex numbers. So you don't have any x-intercepts here. You would have a graph that would look like this. You'd have your x-axis, your y, and that's your parabola. It wouldn't cross the x-axis at all. And that's okay, because we're going to see in later lessons how we would still do that. Now, what is the discriminant of this quadratic equation? Well, that's already in standard form. That's great. If it wasn't in standard form, we'd have to make it in standard form. As it is now, this is A, that is B, and that is C. And remember, the discriminant is the b squared minus 4ac. So here it's just going to be negative 5 squared minus 4 times negative 4 times negative 1. Okay, so 25 minus 16, 9. So the discriminant is 9. That means, because this is greater than 0, and it's a perfect square, that we're going to have real roots, because it's positive. They're going to be rational roots, because it's a perfect square, and they're going to be unequal. We'll have two distinct roots. So let's take a look at what this is going to look like on delta math.
So here we have our delta math assignment. This is another one of our timed assignments. Your time to beat is 100 seconds, and you need 10 of them right. Now I also have open in another tab this. You could also write it into your notebook. It's a really good idea. So that's what I'm going to do. I'm going to hit start. If my discriminant is 0, I have equal roots. So I got 1. If my discriminant is 0 again, that's not a typo. It just happened to give you the same answer twice in a row. Equal roots. If the discriminant is negative 16, well, that's negative, so that means I'm going to have imaginary roots. Discriminant is negative 95. Ooh, negative. Imaginary. Discriminant is 100. Ooh, okay. That's going to be a real number, so it's going to be one of these three. That's a perfect square, so they're going to be rational. Now, are they going to be equal or not equal? Well, they're going to be unequal, because that's not equal to 0. Discriminant is 16. Same deal. Perfect square. So I'm just going to go ahead and say that's going to be real, rational, and unequal. Discriminant is 0. That's going to be equal roots. Discriminant is 20. Well, that's not a perfect square, so that's going to be irrational. 25, that is a perfect square, so it's going to be rational. Between these two, it's going to be unequal. Discriminant is 25. Hey, same thing, real, rational, unequal. Boom, I got it. That was my best time. See if you can beat my best time. So you've seen how to use the quadratic formula to find roots. You've seen how to go ahead and determine the nature of the roots using the discriminant, and you've seen a bit of a sneak peek about how you're going to do that timed assignment. You might be a bit annoyed about that timed assignment. don't worry, I've taken a screenshot of the little table that's really helpful, and I put it onto our Google Classroom page. It'd be a very good idea for you to put that into your notebooks if you have not done so already. So, go ahead, give that a shot, then complete the summary and the reading survey, and I'll talk at you soon.